Okay. So the average height of a Martian is 96. That's our middle. And we know we have 50% of the people on one side and 50% on the other. So how do we figure this out by table? Well, a z-score is what? P hat minus mu over sigma. This is the person you're talking about, or the sample. In this case, what percent of Martians are below 93? So that's your p hat, right? So we're going to say z equals 93 minus 96 over 2. Not hard to do. You've got your calculator. You may notice that that's -3/2, which is what? Now, one of the questions that came up last time is, what do I do with that -1.5? Right? Look up on table. Right? And I want to shade also. So let's shade. Where is 93? 93 would be about right there. And I'm going to color in. This is what I'm interested in. It said, what percent of Martians are below 93 inches tall? It's over here. It's going to be pretty small, right? Because we know that 68% already gone, and all the rest, we know at least 50% are bigger, plus the 34, plus part of that one. It's going to be a small number. So go to your table, look up -1.5, and there you go, right? 0.0668. So this is 6.68%. There's your decimal, there's your percentage. So 6.68% of Martians are shorter than 93 inches. Now this is my visual teaching aid to get you to see what you're doing and where the percent is. In reality, you're going to use a calculator. Now, of course, we know this, and we know this, it was given. And we know the upper, because that's this. What's the lower number? You can either put in 0.001 because you're trying to go all the way here, right? If you're over here, then 100% is under there. Or you can use -9999, right? So try both of those. And I got it to work with a little, I like this better because I'm like, what's the lowest? If we're over here, there's basically no one, but that works in your calculator as well. So take a second, I'm going to pause this and punch that in. You should get the same number in both places. Now you could type -999, which is saying I'm way over at -99.99%, but that'd be the same thing as saying my lower end is basically 0, but you have to put 0.0001. So very tiny, that's the start spot, right? So remember, lower is your left side. Upper is your right side. We started at 93 according to the directions. Then you put in mu and sigma. Okay, so second vars 2. Those are your calculators. Okay. Again, looking at this is so you can get the concept in your head. In reality, at your job, you're going to do it with a computer or a calculator, right? All right, let's try this one. What percent of Martians are above 97 inches? Well, let's recreate this. I gave you the same one, so you can basically copy, right? Plus 1 standard deviation or 1 standard deviation above the mean. 2 standard deviations above the mean, 3 standard deviations above the mean, 1 deviation below, 2 below, or 3 below the mean. So now it wants to know what percent of Martians are taller than 97 inches. I want to know how many there are. Maybe I need to buy them some earth clothes while they're here, right? So just kidding. So 97 is p hat minus mu, which is, what is mu? 96 over 2, because that's the standard deviation. And again, that information was given in the problem. So now what do we have? 0.5, right? So what do we do with this 0.5 that we received? Look up on table. And I like you to use this table because it's showing you all the percents and getting in your mind what that is, and then it adds up to 1. 0.5, 0.6915. And there is extra tables over here if you've lost yours. Now, is this my answer? Let's sketch in what we want. We're 97 inches, that'd be here. And we want to know above, so they're taller. Which way does that table read? Reads left, so it's reading the white part. We want the gray part. So what do we have to do with this number? Yes. Let's write down what? Remember, you can use this on your test, this paper. Must subtract from 1, which represents 100%, because, write this down, you want right side. Okay. Does that make sense what we did? Now let me ask you, what are we going to put in the calculator? What's our lower number? That's going to be the left. What's the left side this time? What's the right side? Yeah, 9999, because it's like 99.999% of the population. Mu is still 96, and it's 2. Let's try it. Second vars, 2. And we get 0.308535 or 30.85%, which is what we had before. I'm going to try something. Does it work if you just type in 100? It doesn't work. You got to do the 99. Well, let me think. I don't know why it won't let you put in 100. Because we're never going to get 100, so 99.99. Oh, I bet I could put 1,000 in. 10,000? Anyway, does this make sense? Yes. Or you could put in, because it's 100%. You could put that in, but you got to add all the zeros. The 9s are easier. All right. Now we did a left. Let's write this down. Left. Yeah. Oh. We did a left one and we did a right one. What's left? An in between. All right, let's try an in between one. Okay. So again, I want you to look. So this was what? 96, 98, 100, 102, 94, 92, 90. And I might collect these notes for a grade, so you better have them with you, or in class kick, either way. Oops. Why do I keep writing this down? Because if I write it, I'm going to remember it. So now I want between 91, where that would be here, and 99. That would be 98, 100, that'd be right here. So I'm interested in these people. Right? That's going to be a pretty big amount, right? Because we know it's more than 68. That one goes way past the 95 mark, but this one doesn't. It's going to be pretty high. So in order to do that, I have two z-scores. Here's z1, here's z2. If I knew z2, and that's all of it, and I subtracted z1, would that leave the middle? So that's what we're going to have to do. z2 minus z1 percents. So what is z2? z2 is 99. 99 minus 96 over 2. And z1 is 91 minus 96 over 2. And we'll get, this is 1.5. This is negative 2.5. And what do we do with z-scores? Look up. So if I look up 1.5, that's 0.9332. If I look up negative 2.5, 0.0062, very tiny, and that should be very tiny, right? If that's the new air conditioning system, I have to move out of this room. Now, subtract. And what do we have left? Okay, so this gives you a nice visual where you look up the top, you look up at the bottom, look it up, and you subtract them. How would that look in the so-called real world? I would go to my calculator, and this time the lower is 91, the upper is 99. Of course, these are the same. And now that one, actually the ones that are harder by hand are easier in the calculator because you don't have to worry about it. Why? That's not my calculator. Here's my calculator. So we're going to second vars 2, and I'm going to say 91, 99, and I made those the same. See, they come out very close. I want you to use your calculator on Delta Math once in a while, because these have so many decimals, that tenths place is off and Delta Math won't take it. We learned that the hard way. Last one. So use your calculator when you do Delta Math. Okay, is that good? Let me leave that up there for a second. If you need to take a minute to write some notes to yourself, write some notes to yourself, right? Remember, you're the one who's going to be looking at this piece of paper when you take your test. What happens if you show up to take your test without this paper? Then you don't have it to use. All right. Different kind of question, but I just wanted to see if you could add it. Suppose the average weight of a Martian is 200 pounds. So that's average, right? They're very slim, right? They're 8 feet tall and weigh 200 pounds. With a standard deviation of 5. So what percent weigh between 193 and 207? So 193, that's about here. 207 is about there. Now let's pretend like we're on Delta math right now, and I don't want to do this by hand. Can you figure out what percent is in here? Of course you can, because that's just going from 193 to 207, and I got a mean of 200 and a standard deviation of 5. So let's plug that in and tell me what you get. That's what I got. I wrote 49, but it doesn't matter. So now let's see what they're saying. They're saying if 716 Martians got weighed, how many would weigh between here? So what do I do with that 716? Well, we know 83.85% would fall in there. So that's got to be what? 716 times the 8.838, right? So if we know what percent fit into this, anytime we weigh a sample, we know that percent of the sample will be in that category. So what do you get? Tell me the whole number when you multiply these. Right? Now, I didn't tell you to round, but let's look at the context of the question. How many? So is this answer legitimate? No, because you can have 0.359 of a Martian. So we would say 600 Martians, right, would weigh between 193 and 207 pounds. Okay. I may not, or software may not tell you to round, but if you're ever counting something that has to be a whole, like how many people, how many Martians, how many dogs, how many cars, if it's counting how many of these would be there, it's got to be a whole number, right? Now, if we're talking the weight of candy bars, we could have 3.5 candy bars, right? I could bring in 3.5 cookies, but I can't bring in 3.5 people. So read the question and that's there. So, right, anytime you know what percent this happens to, then that percent of any sample you take is still going to work, right? So I wanted to point that out in case you didn't notice that before. This is the percent that have that, and this is how many we measured. In our sample, we had 716 Martians. If 83% of Martians weigh this, then 83% of my sample should weigh that, right? Have any of you run into any, we can draw them, right? This is what they look like. They're very slim. Right? I mean, they're 8 feet tall and weigh 200 pounds. That's pretty slim, right? Okay. Find the weight of a Martian with a z-score of 1.25. Well, we have our formula. We know z equals 1.25. We know mu equals 200. We know standard deviation equals 5. So the only thing you're missing is p hat. That's your guy. So we just type it in. Now, how are we going to get that out of there? Right? And what does that give us? 6.25 equals p hat minus 200. So now we'll add 200 to both sides, and 206.25 equals p hat. So you can figure out that your Martian weighs 206.25. You could use this for your ACT score. If I knew that what your Z score was, I could figure out what you made. Yes, sir? Because I multiplied both sides by 5 to get it out of the bottom. Yeah. So the Martian weighs 206.25 pounds. True? True. Maybe he give him a mouth and a little nose. There we go. Does that help review the standard deviation if you've forgotten, and the empirical? Well, we did that last time, but does that help you review this whole thing? Okay, then we'll look at what we're doing today. Very short, very easy, right? I gave you your notes because for whatever reason, they weren't stamped on the back. If you're at home, you've got them, but for some reason when I printed them, they didn't go right. All we're going to do today is look at how hard is it to count how many are available. Simple. We're going to do it the hard way first so you get a mental image, and then we'll say this is too hard. Okay? Or too time consuming. Let's suppose you need passwords. Let's say I need passwords for my students. And the first character must be an A or a B. The second character must be a 1 or a 2. And the third must be an X, a Y, or a Z. How many codes can I make? Would that give me enough passwords for the class? Let's check. So the first one is A or B. Then I give you your second character, and that's 1 or 2. Then I give you your third character, which is X, Y, or Z. X, Y, or Z. X, Y, or Z, or X, or Y, or Z. So I can now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 options. Is that going to get me through class? No. It was like 60 of you between two classes. What is the sample space for this? Just to review that word, what's the sample space? It'd be what? A1X, A1Y, A1Z, A2X. What is the sample space again? Yes, we don't want to write this if our sample space was too big, but let's write it just to review so we don't forget. I might want a list of all the passwords so that if a child forgets his, let's say I put you in alphabetical order, I could be like, oh, you're the third one, you're A1Z, right? Well, why did I do that? I should put B1Y, B1Z and keep them in order. B2X, B2Y, B2Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's easy enough if I have a small group. What if I wanted passwords for the 1,400 students that come here? I really don't want to do this. There's got to be a better way. Well, there is. How many characters did you have? You had 3. So well, character 1, character 2, character 3. How many options do you have for character 1? A or B, so that's 2. How many options do you have for character 2? It's 1 or 2, so that's 2 options. How many options for character 3? Well, we have 3 because it can be X, Y, or Z. So that's 3. What do you get when you multiply 2 times 2 times 3? 12. Notice, right? This is a very special phenomenon. It's very fancy. So if someone tells you to use it, you'd be like, you just want me to multiply 3 numbers? Or 2. This is the fundamental counting principle. So if someone tells you to use the fundamental counting principle, don't get freaked out. You're just going to multiply some numbers together. All you do, how many choices, and how many choices, and you just multiply them, and that will tell you how many codes you can get. Very important, right? If I want to do zip codes in Texas, I need to know how many cities there are, and will 5 numbers do it, right? So we oftentimes need to know how many of something that we can create. So let's do a couple. This starts tomorrow down here, but there's just a couple problems here. They're very easy. Again, I just wrote down the rules, right? So you are framing a picture. The frames are available in 12 different styles. Each style is available in 55 colors, and you also want a mat board, which is available in 11 different shades. How many different ways can you frame the picture? Well, what do? 12 times 55 times 11. What is 12 times 55 times 11? 7,260 different ways, right? One more vocab word and we're done. Does that make sense? You just had to multiply them. Okay, the standard configuration for a Texas license plate is 1 letter. So I'm going to write letter followed by 2 digits. So digit, digit, followed by 3 letters. Letter, letter, letter. Is it going to be the same independent or dependent on what my order is? Yes. So this one is also going to be a letter followed by a digit. Whoops. Followed by a digit. Followed by a letter. 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 That's the way we make our license plates, right? And it tells us here 2 digits followed by 3 letters. Got one letter, 2 digits, 3 letters. How many different license plates are available if the situation is independent versus dependent? Independent means letters and digits can be repeated. You could have an A and an A. Dependent means nothing can be repeated. Once you stick a J on there, there's no more J's. So let's look. How many options do you have for letter number 1? 26. Digit number 1? How many digits are there in our system? There's 10, 0 to 9, right? How many digits do you have to pick from for the second one? 10. How many letters? 26 each time, right? Because we're allowed to use the same letter twice. Now, how is that going to compare to the dependent side? My first letter still has 26 choices. My first digit has 10, but now how many choices do I have for the second digit? 9. How many choices for the third letter or the second letter? 25. Now just 24, and now just 23. So punch those in and see the different numbers that you can get. I'll show you what I got, but I was punching fast. It could be wrong. So with a license plate and these restrictions, we can make 45 million license plate. Is that enough for Texas? Do we have more than that many cars? I don't know, but it's different for trucks. So we can't count trucks. And we also have people can buy a license plate, right? You can put your name or something funny, like math is great, right? Does that make sense? See, I'll make you feel better. How many of you ever said you don't have anything to wear? Who doesn't have enough clothes? Okay, let's test this theory. Jen, let's just go with short sleeve to make it simple. How many short sleeve shirts do you have? Estimate. 30? How many pants? 3? How many shoes? Well, let's go here. I know this is, how many jackets? So let's see how many outfits you have. Now I realize everything's not going to match, but how many outfits does she have? Let's see, you'll feel better. So I don't think you're lacking there. You got 7,560 different outfits. How many years will it take you to wear all those? Divide by 365. We can make math fun, see? And what is that? Yeah, 20.7, almost 21 years for you to wear everything. There you go. You have 20 years worth of clothes. You're good. Silly, but it allows you to figure out combinations. You could do it with pizza toppings, ice cream toppings. How many sundaes can you make from 3 flavors of ice cream, 3 toppings? And yeah, anyway, we are going to work on Delta Math.